Okay, but thank you, Shushmita, for inviting me again for this nice webinar series. I am fortunate to deliver and share my thought on the research work of the cognitive radio and IoT. And today I have decided to give the requirement of cognitive radio and IoT, its standardization process, and a clear demonstration that we have built in our laboratory. So it's a practical demonstration. I think people will love to see that demonstration also at the end. Now, how much time I have? What time I have to finish, Shushmita?
Madam, as we have started slightly 15 minutes delayed, so you can carry up to 12:45.
Okay, so 1 hour is my time. Okay. I welcome all the participant and the organizer in this event. So the outline of my topic is a definition and brief discussion of IoT and cognitive radio, very brief. Motivation of bringing IoT and cognitive radio. This is the main interesting part. Why should I go for cognitive radio and IoT? Some challenges and standardization effort needed for IoT along with Seer, because until we do standardization, bringing both the platforms Seer and IoT together, we cannot get the uniform access all over the globe. So this is very important to understand why we need to move out all the challenges for the standardization process. Then some application areas on which IoT research can be done. Actually, the participant and young researchers should motivate on the application part and search on their own what could be the contribution area in future. An example, IoT enabled Seer network in W-band that we already have performed in our laboratory, the practical demo for the W1 Seer IoT network. This is all about my presentation outline. Now I shall start from the quotation. Recent research and technology trends are shifting towards IoT and CRN. However, we think that the thing-oriented, internet-oriented, and semantic-oriented version of IoT are meaningless if IoT objects are not equipped with cognitive radio capability. Equipping IoT object with Seer capability has led to a new research paradigm of Seer-based IoT. This quotation is taken from a journal, IEEE Wireless Communication, published in the year 2017, and that paper written by Athar Ali Khan and ATL. So both Seer and IoT are the new technologies with enhanced demand. So we have to cope up the technology trend and learn something. So the first part of my presentation is related with IoT Seer definition and possible application areas. So what is Internet of Things? Everybody knows the definition nowadays. So extending the current internet and providing connection with the communication and internet networking among the devices and physical objects that are considered as the things is referred as the Internet of Things. You know, the picture shows you the growing up scenario from 2003 to 2020. The big amount of things would be connected to the internet at present day technology. So this is the exponential growth of IoT is due to the massive growth of low cost devices, because in today's context, because of the low cost microprocessor and high integrated circuited VLSI based circuited, we can we can have the low cost devices. Advancement of wireless network also growing up. We know from the starting end of 1980s onward, 1G to 5G. Today we are talking about the 6G deployment. So advancements of wireless technology also tremendous, and we on the platform of the wireless technology, along with the devices and internet connection, we need to build newer and newer application that will fulfill the IoT requirement. Here is an example scenario that I have put on to understand the participant what is actually required. We should have the wireless network, and the things, maybe vehicle, ambulance, or hospital system, or home appliance, everything need to be connected to through a internet media to the network for a proper communication with the developed infrastructure. This is what is called Internet of Things. Now, some more definition. IoT is the interconnection of different objects through the internet using different communication technologies. I already mentioned it. The object equipped with the internet should be sensor based, and the communication module should be there. Until the sensing operation would be there, we cannot understand what should be the communication requirements. So we need to build the communication modules and sensor on the Internet of Things. With the recent development from machine to machine communication, IoT is changing our life by connecting the several devices to the internet and mobile technologies, and a new paradigm of IoT MT, which is known as Internet of Mobile Things, are emerging. So this is a worldwide network to be interconnected, uniquely addressable based on standard communication protocol, and people wants to have the connection at any time, at any place, and anything as a service through a network path and to get any time services. So there is a good paper presentation in When Cognitive Radio Meets the Internet of Things, published in IEEE conference, 12th International IEEE Communication 2016. It's a mobile computing conference. Now, we need to have the idea about the cognitive radio, which is also a new paradigm. Cognitive radio is a newer concept that brings a concept shift as a well-regarded agile technology. The word agile is very important to notice. Agile means flexible. So cognitive radio allows opening up the frequency band to concurrent operating user. That means when there are several concurrent operating users simultaneously within a domain, cognitive radio concept allows some spectrum agility for the opportunistic user. It has two type of users. One is the primary user, other is the secondary user. The primary users are supposed to be the licensed user, and the secondary user non-licensed, because we do not have the infinite radio resources. We all know radio resources are very natural resources, and it is limited. So suppose within a particular place, the geometrical location, 100 user base is the maximum, but our requirement for the 200 users base. So we need to plan a method to give the 200 users in such a way that with the limited resource we can provide services. So cognitive radio is such a concept that when the primary or licensed user are not using the radio spectrum, as you see in this picture, the power, frequency and time within a particular geographical region, there are several idle spaces. That is the primary user not using the spectrum here. In that case, the secondary user who do not have the license because of the spectrum scarcity, or because of the cost of the spectrum, one cannot buy the license. In that case, they may seek the opportunistic use of the ideal spectrum within a geographical region at any time, at any place. This is what is called cognitive radio. So in a Seer objective, to sense the spectrum holes, that is here the spectrum holes are finding in real-time RF environment. The word cognitive means intelligent. Cognitive is smart and alert and can handle dynamism within a network architecture. So there are three key features of the Seer. One is the sensing, which is the most important part. Cognitive radio need to sense the radio spectrum environment to find the spectrum hole. So this is called cognitive capability. Analyze and learn the sensed information, because without analyzing what is happening and what is going on, the intelligent use of those spectrum cannot be possible. So it has a self-organized capability. And finally, a decision-making process has to be there, or spectrum agility from movement of the users from one domain to other domain is possible to adopt the radio environment, which is known as the reconfigurable capabilities. So the key features is cognitive capability, self-organizing capability, and reconfigurable capability. These three constitute the cognitive radio environment. So spectrum, we know spectrum, radio spectrum is very, very costly. One cannot buy, and it is controlled by the FCC, the Federal Communication Commission. So spectrum leasing is sometimes bears low cost than the spectrum buying. So purchasing spectrum is a huge cost. So cognitive has a significance of communication by using the opportunistic radio spectrum to provide a low cost solution. So in a growing world of internet connectivity, day by day, the number of wireless users are growing exponentially. So in that particular age, the bringing the concept of the cognitive radio has a tremendous significance that may offer the natural solution to cope with the exploding random and diverse mobile data traffic into the world of 5G and 6G. So there is a consensus among the Cr, IoT, and 5G communication. So we need to analyze a suitable direction for using cognitive radio and 5G communication to apply a IoT application. The Seer 5G consensus with the Iot application has to be analyzed properly with the development of so-called technologies around the globe. So interestingly, the Seer and IoT 5G all are the new domain. So there lies some challenges and standardization process yet to be done. Some are going on. So from the Ericsson point of view, there is a definition what is called cognitive cellular network. Cognitive cellular network is a network that integrates conventional licensed cellular radio and cognitive radio into a holistic system, and that will provide a promise paradigm for the 5G mobile communication system. Cellular network, though, have the ubiquitous or all around preferred choice for the access network, but lack of communication resource might be a problem that I already mentioned. Here lies the significance of using cognitive radio in some way. So literature survey revealed the following facts. What is those? The 5G would be IoT enabled. We already have seen there are several applications is developing around the world. It requires high connectivity speed. 5G has a high speed of connection and connecting billions of machines at a time. So creating severe spectrum limitation, resource limitation. Bandwidth is an useful resource for any communication technology, whether it is a wired or wireless. Wireless radio technology, the bandwidth is the most important resource because we cannot create radio spectrum. What we have in nature, we need to use judiciously. So the significance of cognitive radio will be tremendous in the future development of application which is bandwidth intensive. Large amount of heterogeneous data traffic, that is human machine type, only machine to machine or combined type, are the some of the features of 5G network connection. We also know that Seer is a smart system. It can sense, modify, and act according to the radio environment. Also, we need to build the intelligent communication system for the IoT application by bringing the intelligence of the Seer. So 5G would be the combination of Seer IoT enabled smart system. Technologists find the new solution of using these costly spectrum resources that would be used for any wireless communication, and it is an intensive research area. Now, what is the main motivation for Seer and IoT? The main motivation is to manage the bandwidth, the radio spectrum, bandwidth allocation for IoT object. So as the number grows, normal spectrum management is not possible. So allocating the spectrum bandwidth and managing it judiciously without interference is the most important aspect for any communication, because if we have the channel access but interference will damage our communication, the wastage of bandwidth would be there. So spectrum management is a very, very important aspect for CRIOT motivation. Additionally, the number of licensed users, that is PU, are growing on. So peak spectrum assignment policy is not applicable, and it will incur the much more cost to purchase the spectrum for the fixed spectrum assignment. So spectrum assignment for such a large number of objects can create unnecessary expenditure. In that aspect, cognitive radio may help. Again, IoT object would be equipped with cognition in order to learn, think, and make decision through understanding of both social and physical world. That is, the IoT object that will enable by the sensors and the communication module need to be cognitive radio enabled, which is smart and intelligent. Then only we can properly manage the radio spectrum in a dynamic environment that may alleviate the requirement of the fixed spectrum assignment strategy, which is very much costly. So we require intelligent decision making process in the IoT object. Perception action cycle need to be there. That is the part of the Seer. Massive data analytics need to be there. We know big data analytics is another domain of research in present day scenario. On demand service provisioning is because day by day newer and newer applications are coming, so at any time, at any place, user may require very demanding subscription or service. So we may we need to satiate the user requirement in a meaningful way through IoT Seer application. Semantic derivation and knowledge discovery is also the part through the intelligent network. So Seer-based IoT is a foreseeable need in the future. So this is what is the motivation. We know cellular communication incurs cost, but it has a long range communication. On the other hand, Bluetooth, Zigbee standardization are the low cost solution, but had limited range. So by that time, there is a IEEE standard 802.22, which is a wireless regional access network WRAN and Seer based analogy. A CRN standard that has long range and may be suitable for short to long range application. So this is the standard. So Seer based IoT framework can alleviate interference situation by looking for interference free channel, because it has a intelligence and cognition. It can handle the dynamism within the network and can sense and allocate the spectrum in such a manner where spectrum holes and find are found, and that way the interference among the concurrent user may be alleviated. So Seer intelligently can allocate the radio spectrum in such a manner through the dynamic spectrum sensing that may alleviate the interference situation. This is the thing. So mobility will be an important feature of the IoT based structure. So when we are the things are mobile, the continuous communication would not be possible. So to facilitate the seamless communication among the mobile IoT based structure, cognitive capability would help. IoT object can achieve seamless connectivity using the use of the Seer. That is another motivation. To support big data that would be generated from the huge number of IoT objects in the future and present day scenario, and semantic derivation issues, a new paradigm of cloud server is gaining popularity, because we need to have the data to be sent to a server for and then collect for proper analysis and application. So Seer based IoT object will automatically search the available storage places in the cloud server, and those through the spectrum sensing suitably and send the data through the cloud server. This is another interest why Seer IoT should be Seer enabled. So this is just, I have clicked a page on the Ericsson, whether the Seer 5G communication, any IoT based solution is there or not. This is not Seer enabled, only 5G IoT communication. What is that? On the 5G communication platform, they demonstrated a real-time interactive communication for a patient carrying by a ambulance while taking to a hospital at a remote end. The serious patient condition through a IoT platform and video conferencing over the 5G network, the doctors could and nurses can help the patient what to do till they arrive to a hospital. So emergency services may be provided. This is the this slide give you the idea that it's not only on the theoretical aspect, but all over the world the industry are playing a tremendous job that may help the people in a very interactive real-time service. This is one example. Now, there are several applications of Seer-based IoT. I shall outline some of the few application that is related with the IoT solution so that participants may find their interest and search to dig out in a bigger aspect. What are the present scenario where we can researcher may contribute. You know from the previous slide that healthcare is one of the most important or required domain, most sought domain for where Seer-based IoT application may be happening. At the end of today's presentation, I shall give you one of the example that is related with the healthcare. So patient monitoring is such application already in practical fields that I have shown in the previous slide. So smart sensors are deployed on and around a patient body to monitor critical data such as temperature, blood pressure, glucose level, and others, and can be sent to the distant end to the doctor over a communication platform. With remote monitoring, medical staff continuously observe the patient condition. So Seer-based IoT framework can achieve this to long range without any worries about spectrum availability because Seer can allocate in a dynamic spectrum environment through the continuous sensing. Now, social application and activities is going on Seer-based IoT. As for example, in the intelligent transportation system ITS, which incorporate the road and vehicle-based sensor for traffic monitoring and electronic tolling. So the vehicles and RSU, roadside unit, will be intelligent IoT devices, Seer-based IoT devices that can monitor the present situation, take the intelligent decision, and orient their communication link. So ITS, the intelligence, which is a very mobile environment, may be the future application of communication. So in ITS, there are already some dedicated short-range communication known as DSRC with a channel bandwidth of 10 megahertz in the 30 megahertz to 70 megahertz band. Another band is 5.8 to 5.9 gigahertz. This first 10 megahertz, this band is for United States, and 5.8, 5.9 is Europe, respectively. So short range communication is used for alarms and emergencies. That is accident, where within the roadside unit, some emergency situation may arise because of the accident, some road block will be there. So alert generation and emergency service provisioning is the purpose of establishing the short range communication using DSRC protocol over the cognitive radio platform. Long coverage requires many roadside unit because to make the long coverage through a wireless platform on the ITS system, you need to have place many RSC unit, roadside unit, which is cognitive enabled. Okay, but placing the roadside unit, which is intelligent Seer IoT device, will be require a cost, sufficient amount of cost. So assigning communication technique is not studied thoroughly in this technology Iot. There are a lot of research may be undergoing and may be done in future prospect to see the proper use of Cr IoT based application in the intelligent transport system in the developing country. The developed country already have applied something, but people, country like India, there is a huge opportunity to avoid the traffic congestion, accident, and other thing. If we can build the proper roadside unit and intelligent algorithm with the help of Cr IoT based application. Seer may find the opportunistic use of the radio resources. So from periodically when they find some idle spectrum within the roadside unit, they can communicate over the network to send the traffic scenarios time to time. This is what is the use of the Cr IoT based application. So Cr enable ITS may be a suitable research area. Now, environment related application, this is also very important and already being used in progress. That is waste management, noise and temperature measurement, humidity estimation, and monitoring the carbon level emissions are some of the key areas where possible CRIT application may be a possible application. So spectrum assignment for this large number of devices for waste management or other application that I have mentioned it here would be a difficult task through a fixed assignment policy. So if we apply the Seer, the cognitive capability with that sensor, then IoT functionalities can be a potential solution for network congested and scarce radio resources. So Seer enabled IoT, not only the IoT application only, but IoT with this cognition capability using cognitive radio network may help for the better spectrum management instead of fixed spectrum over a large number of sensing devices for waste management and other applications. In-home appliance already in America, Australia, and many developed countries is already there. What is that? The home appliances are internet connected. They can make a ad hoc based network through the Wi-Fi based management. Yeah, for the application of smart fridge, smart light using sensor. So if every home appliances, what is the difficulty? Home appliances are basically based on the ISM band, that is industrial, scientific, medical application band. So several use application within the same band may cause the interference. So to avoid the interference possibility, if all the sensor and devices are CR enabled, then cognitive users may find a orthogonal channel for data transport avoiding the interference. So in a non-interfering manner, to reduce the interference condition over the same ISM band for home appliances, the cognitive capability would be an essential methodology. Smart grid, another area. Smart grid is an emerging paradigm nowadays. So consumer want to know what is their power consumption. They may ask at any position to the vendor, that is what is their total consumption, the time at any place. So if the power provider need to answer this thing, they need to apply some sensor devices on the smart grid. So placing huge number of sensors would generate the large amount of cost for the communication. Though digital subscriber line or optical fiber and wireless technology, these are the solution methodology, but placing optical fiber and digital subscriber line would be a costly effort. So if we use the available wireless technology enabled with the Seer, then this cost may be reduced. So CRN is a viable solutions for smart grids application also. Smart cities. We know nowadays a big thirst is going on for smart city, smart village development. What is, when we call it smart? Smart means again which has cognition, alert. So the objective of smart city is to design the urban city or village area with the help of ICT, that information and communication technology. So smart city system, every system, as for example the banking, payment, weather reporting, or anything, that any type of e-services that you may use over the digital platform through a mobile network or any type of fixed network, and that is with the application of the ICT, is known as the smart city design. So with the higher and higher requirement of e-services within a city area, so we can convene the smart appliances, that is healthcare service, education service, etc., to facilitate this sort of service, continuous connectivity with information and communication system as the backbone network required the huge amount of bandwidth. So the spectrum scarcity or network congestion is the result. So in that particular case, to reduce the ideal, to for the use of the ideal spectrum, the CRN may be inbuilt technology with those smart city sensors for better interference management and better spectral uses. So data gathering and user interaction will also be the important aspect for such an city application. Finally, Internet of Vehicles is another new paradigm coming on. That is, vehicle would be integrated with the communication control and embedded system for autonomous navigation. So IOB is expected to be an autonomous decision maker for traveling through the safe navigation. This is very important. The word safe is very is the quality of service for IOV. So with the help of communication control and embedded system, the IOV domain would be using the autonomous navigation that requires information exchange from vehicle to vehicle, from sensor to sensor attached with those vehicles. So availability of the spectrum of mobile vehicles would be a challenge. So CRN be a good solution to be integrated with that system for the long range and interference free spectrum management in this sensing environment. This is the sum of the highlights I have provided for the Seer IoT and possible Seer IoT enabled applications. Now I will move to the standardization efforts by different bodies, both for the IoT and CRN. As you know, without standardization, the uniformity of the access of network and information would not be possible. So prior to the application, we need to use the standardization effort. So several standardization effort are already going on in the domain of IoT and CRN by parallel. So for IoT, creating a generalized framework for IoT with heterogeneous devices and technology support requires interoperability across products. You know, we may generate a product, but it cannot be integrated with the other product. Then the two products cannot communicate each other when attached to a particular platform or communication network. That is they are not compatible. So interoperability would not be a possible thing. So whenever we can use any standardization method, then we need to connect in such a manner through the available spectrum, available network, that is interoperability is the possible thing. So interoperability across product, application and services, that preclude vendor lock-in. Actually, if vendors are not follow this aspect, then possible application areas would not be the ideal solution. So global standardization of the IoT is the only solution to this. So for standardization effort in the IoT, many national and international standard bodies working together, and there are many open areas to debate and standardize, like reconciling country-specific efforts, empowering local solution, etc. So I suggest you to see these two papers. One is that I already mentioned, cognitive radio-based Internet of Things, published in IEEE Wireless Connection, and another paper, book chapter in Springer book chapter, Internet of Things, published on 2018. They have detailed discussed about the several available standardized technology in these two papers. So I have taken the help of this paper for taking data on the standardization effort. Standardization efforts are required to bring IoT into the personal and commercial perspective to avoid excessive fragmentation. Excessive fragmentation means each of the vendor are building separate application, separate standardization method. So excessive fragmentation is not the suitable practice. Attaining interoperability, scalability, and efficiency are the chief recommendation while we are applying the following the product development. So we have to follow a standard specific method for this development. The number of standardization bodies, working group, and technical committees on the IoT platform are the IEEE, the National Institute of Standard Technology, Internet Engineering Task Force, and 3GPP. These are the international body, and where the European Telecommunication Standard Institute, ETSI, is known as the regional body. Telecommunication, apart from the international and regional, there are country-wide development society. In India, the Telecommunication Standards Development Society, TSDSI, or Global ICT Standardization Forum for India, GISFI, GISFI, Bureau of Indian Standard, they are there for the Indian part. In the Korean Agency for Technology and Standard is there. So these are some of the example I am giving for local and international and regional IoT standardization effort. Yeah, you can one may search the standardization in the internet, Google, so you may get the detail of it. So what are the deployment issues where we are considering the IoT framework? Improvement in connectivity in terms of data rate, availability, and the cost. Whether the network availability is the is a question. So data rate also very important. Within a very congested network, we cannot get the emergency service. Cost is another aspect. So wide adoption of Internet Protocol IP as the basic infrastructure addressing mechanism for the things. So things to things connected with the worldwide operation based on Internet Protocol is the connection mechanism. Another thing, the miniaturization of computing and communication. So miniaturization of computing, we cannot evoke large computation that will require the large amount of energy. Obviously, if computation will be large, then communication time will be also large. Again, when computation and time of communication would be large, it will occupy most of the time the higher band. It will occupy higher time for the bandwidth. So bandwidth consumption would be high. So miniaturization or short communication time would be the most important aspect while developing any protocol on the IoT based platform. Advancement in data analytics is also another important aspect, because if we have large number of data but we cannot interpret and what to do with those data is meaningless. The purpose of establishing the IoT enabled communication infrastructure would get lost if we cannot extract the meaningful data. So rise of cloud computing along with cost reduction in storage system is also another aspect. That is the why cloud computing gaining importance with the advancement of IoT development. You may understand that is huge amount of data need to be stored, and that to be with a low computation aspect, low computational time and complexity, and huge storage device would be the requirement. So while considering any product development or standardization process, we have to keep in mind several IoT deployment issues. Now, the Standard Development Organization SDO under the ITU, IEEE, Ietf, 3GPP and 1M2M, machine to machine, these are together is known as the Standard Development Organization. These have traditionally performed a great role in defining technology standard over the problem space. So, specified either policies or generic reference architecture. Their purpose is to specify policies and generic reference architecture or offer standard protocol to carry out the communication. IET's effort is to provide the low power wide area network LP1. This is most interesting because low power is also the important aspect to save the battery life. Even wide area network has the capability for long range communication. IoT standardization with International Telecommunication Unit under the body of Study Group 20, SG20. So that has been in charge of IoT and its application, including smart cities and communities. So these study include the semantic aspect, big data analytic aspect, accounting and charging aspect, identification, security, privacy aspect, etc., etc. These ITU also define some of the reference architecture for smart infrastructure, manufacturing, and industrial IoT, e-health, and e-agriculture. These are the evolving technology going around this thing. IEEE is the most important body. You know, this is the IEEE webinar series. You know, IEEE is continuously developing the standardization process for technological development worldwide, and the local and personal area connectivity in aspect of this. Only the role of IEEE is to forming the physical and MAC layer standards. So IEEE Standard Association under the project P2413 aims to come up with the architectural framework that covers the needs for different application. It considers the IoT as a simple three-tier architecture with application networking and data communication and sensing. Three-tier architecture. So you know, wireless LAN, which is brings the IEEE 802.11 family together, is still a practical MAC standard for using the IoT for developing the IoT applications. Low PAN technology is standardized under IEEE 802.15.4 Bluetooth technology. IEEE is taking an important role in defining physical and data link layer. So these are the IEEE objection, IEEE contribution. With Ietf collaboration, with the IEEE and other standardization body, what Ietf does, it ensures compatibility of devices across the internet. So IEEE has been instrumental in standardizing the security, authentication, architecture, data, and physical link layer, where the Ietf ensures the compatibility of devices across the internet. So you can get the different IEEE standard association and internet things in this website. Now there are other IoT standardization with 3GPP that produce the specification for cellular communication through narrowband IoT. So 3GPP is responsible of developing narrowband IoT solution. So what is it? Radio standard developed for low power 1 or LP1 to support IoT technologies. NB-IoT is designed for mainly indoor coverage using large number of connected devices for very low cost and low cost solution with long battery life of the order of 8 to 10 years. So salient features of the developing narrowband IoT by 3GPP third generation partnership project, the well-known body in wireless communication development, are the less operational power consumption for battery long life, reduced component cost because we need to have the low cost solution for the common application resources for common people, common mass, etc., and low data rate. Data rate cannot be huge. If for higher data rate, the battery life consumption will be higher. So with a low data rate, the less power consumption would be required, reducing the cost of the component. This is the main focus of developing narrowband IoT. IoT standardization Internet Engineering Marks Course I already mentioned. Main objective to make IAP enable services with the other standard like IEEE, 3GPP and ITU. As for example, IPv6 over LP1 working group is formed to optimize the IET protocol, offering for the different lower layer of offering of low power one. As for example, for Sigfox, LoRa, Alliance, etc. So how does the IPv6 protocol would be integrated for providing the IP solution in the developed IoT solution or by IEEE standard 3GPP or other in ITU. So this is the very simple example IoT offerings for Ietf physical data link layer. So this spectrum will be this physical layer issue is based on several parameter standardization parameter supported by IEEE 3GPP ITU. So this is the domain of the standardization bodies. Now low pan adaptation IPv6 network, this is the work for on behalf of IETF, GCP UDP protocol, then security application. So IETF takes care about these connectivities in a very secured manner. So achieving ultimately IoT enabled application in the industry automation and predictive maintenance, we require a suite of processes to extract the data from connected devices, and that data need to be analyzed for various types of data input. We need to identify the data patterns and insights to develop industry specific applications. So big data analytics emerges. Terms like software as a service, platform as a service, as for example UPI platform for payment system, Uber is a platform, and artificial intelligence AI are currently being used to describe the different types of solution offering as IT ecosystem. So this is all about standardization. I have summarized some of the standardization body with their area of focus. When I shall share the slide, you may see in detail. Similarly, you need to standardize the CRN. The first CRN standardization effort start in the United States for giving the ideal TV bands for wireless applications. So there are several technical committees on behalf of Cognitive Radio Network. One is the IEEE 802.11a modification of Phi and MAC layer for IEEE family. 802.19 wireless standards coexistence with IEEE 802, and IEEE 802.22 use. This is only technology nowadays used for Seer technology for rural broadband wireless access under TV white space band. So several other standardization effort is going on CRN part, but the CRN standardization process has to go a long way if the Seer enable IoT need to be applied in future development. So the issues, challenges, research direction to design the Seer and IoT. The effective utilization of Seer requires the good hardware design. So if the Seer antenna is used in the cellular communication for long range, it will not be applicable for the ISM band 2.4 gigahertz. So the antenna structure for one band to other band would be different. So these are the issues we need to solve for spectrum uses ideally, along with the communication underlying communication protocol. So Seer is basically a complex system, not a very easy solution. Furthermore, the transmission power need to be organized depending on the type of the application. Seer has to be designed in such a manner that it is application specific for low power transmission to high power transmission. Now another challenge comes how to connect the gateways to IoT object. You know, gateway is the gateway to connect the IoT objects into the internet connectivity. So gateway would be the large internet device connection point. So it has to be designed in such a way that may provide the required flexibility, scalability, security, and energy efficiency. So IoT object most of the time are energy constrained, battery powered. So gateway can be designed which would be IoT Seer enabled in such a manner that on behalf of the spectrum sensing of IoT object which is battery constrained, power constrained, may the gateway can perform the sensing. Okay, so these are the design issues, some of the design issues. So in case of Seer based IoT object, additional requirement arise in the form of efficient spectrum resource utilization, particularly in a multi-user scenario. Seer users search for spectrum access individually, so where to place which communication need to be decided very judiciously for better spectrum management. So geolocation based spectrum searching based on some previous history would be the more preferred option. So flexibility and interoperability may be achieved through the software defined radio use. We know nowadays software defined radio gaining importance, very much importance for Seer application. So it has the reconfigurable structure. That is why Seer is the reconfigurable radio unit. So software defined radio would be most important component in the Seer IoT enabled architecture. Semantic data analytics, I already mentioned some of the thing. The volume of data from Seer based IoT object in the future pose a big problem. Collected data is meaningless unless we properly analyze and interpret it. So it has to be segregated in such a manner the high dimension and non-linearity can be separated. Effective algorithm design with semantic capability that is capable enough to support linear and non-linear and high dimensional data processing. This is the requirement for on the part of the semantic data analytics. And discover cognitive application utilize the learning and reasoning algorithm and select processes based on history which may consume time. So it is necessary to discover advanced knowledge based algorithm or predictive algorithm for improved performance. So not only the device aspect, hardware design aspect, some of the underlying software for semantic data analytics and knowledge based algorithm, which is again low consume less time and less power. This sort of algorithm design is also necessary. Okay, so spectrum related function in the Seer, what is that thing? The number of pews when present in the same band, the interference is the obvious thing. So Seer has to be intelligently put the users into a proper band. So differentiation between licensed and unlicensed signal is also important. Spectrum sensing takes time and consume energy. So fast and energy efficient algorithm should be designed. Multiple radio can be deployed with the Seer with the multiple antenna system. Advanced geolocation based and history keeping algorithm need to be posed to avail the QoS parameter. So these are the various directions. Standardization activities and challenges on Cr IoT framework may have to be support a large number of diversified devices. So communication standardization involve communication protocol at each layer, object selection and transmission power. Activities need to be carried out jointly around the globe, so efforts have to be streamlined and quick to save cost. Heterogeneity in Cr IoT framework has a security problem because in the Cr cannot apply the same security level to all situation. So adaptive capability of Cr can become a security problem when an intruder may pretend to be a Cr. So it is not the actual user, but it may pretend like a Cr. This security threat will be there. So these sort of issues need to be solved. Security is also a big challenge in the Cr environment. So I don't have much time. In this period, I shall show you real-time Cr IoT WBAN application for a healthcare system that we have developed. What is called the smart health monitoring is one of the application for smart city design using modern communication infrastructure, that is IC. Some of the hard facts that life expectancy in India on the rise, but quality healthcare service is still inadequate, and healthcare service in India are not uniform. India is facing a very challenge in for heart, stroke, obesity, cancer and diabetes, this sort of diseases. So premature death less than 70 years happening very often on stroke because of the cancer and obesity, etc. And cardiovascular, diabetic and chronic respiratory disease give almost 68% death globally. And I have taken a WHO analysis, that is coronary heart disease in India. This is the highest rank. This is rank per year, almost more than 12 lakhs people died. And in Japan, this is the third position. In comparison to USA, the death in India is very large. Obviously, the population is also large. So we need to combat a very technological solution to monitor elderly people or on a chronic disease, people having chronic heart diseases. So to avoid deaths of millions and lack of timely diagnosis causes the death. So we need to provide a prevention which is better than cure. So new era of preventive healthcare system will be the emerging solution for proactive wellness management. So wearable monitoring system capable of early detection of abnormal condition, resulting in major improvement in the quality of life in the smart health monitoring system. So the candidate is the WBAN, a futuristic scenario for smart medical health care. This is taken from the IEEE Communication Survey and Tutorial published in 2017. The concept is like that. That is, today we are facing a nuclear family, elderly parents living alone and becoming common. So to monitor their health, we can use the inter-WBAN that will be connected to a personal server to internet. So in the first tier 1 band, the different health parameter issues consisting the WBAN, inter-WBAN area may collect the data, and through the personal server, it may connect it to the gateway internet server for inter-WBAN communication, and that through this internet connectivity, it may send to the proper authority of the hospital or the very close kin, etc., for emergency services. So three-tier healthcare system is developed. In the first tier is consisting the body parameters. Second tier is the data transport from access point to the remote server point. So this three-level architecture is the possibility. So people connected with things is basically Internet of Things. So when you connect the WBAN, to the various sensor, it will propose a W-band network, and we can call it the IoT application. So number of tiny wireless sensor strategically placed at different places of the body, human body, create W-band, can monitor various parameter as the vital sign, providing the real-time feedback, and that W-band are expected to cause a dramatic shift in how people manage and think about their health, similar to the way the internet has changed the way people look information communication. So what is body area network? It is the IEEE standard, the 802.1.156 standard, providing the low power short range communication on the human body, extremely reliable wireless communication within the surrounding area of the human body, supporting a vast range of data rate starting from 79 kbps to 15.6 kbps ultra wideband for different type of application. W band may interact with the internet and other existing wireless technologies like Zigbee, wireless sensor network, Bluetooth, wireless LAN, WPAN, video surveillance, etc., etc. So opportunity to build IoT application. So the aim of W band actually to maintain the chronic diseases and to generate the alert situation for critical healthcare issues. So managing illness and crisis, detection of abnormal condition, so resulting in major improvement in the quality of life to be expected. It W band healthcare system may be applied for every elderly and chronic disease. So we have shown a cognitive radio backhaul network a suitable choice. So what we did, we this is the proposed W band enabled W band Seer enabled IoT application on a using the licensed wide area network one and the Seer based communication, which is our contribution. We have shown that if W band network, which is very easy based to develop using different sensor following the IEEE W band standard, that sensing would be communicated to this W band gateway interface to be connected with the licensed wide area network or Seer based backhaul network. So designing the body network controller is the challenge. Our contribution lies in designing how the body network controller is designed. That is why we call body cog architecture. That is W band cognitive radio architecture. It has two interface to be developed. One side is the W band interface, other side is the cognitive radio interface and the WAN interface. So designing the three types of interfacing within the body radio network is our research contribution, and that to be the Seer enabled that is opportunistic use of the information to be transported through a gateway to be connected to internet to the server, or through the licensed wide area network to the gateway to the server, that is healthcare application part. So bodycock support ubiquitous remote healthcare monitoring, sending W band sense data to remote server here using Seer network as a backhaul or a WAN network as the licensed network when the Seer, that is non-availability of the opportunity spectrum, is there. So for emergency service, you may need to provide the one body area network, which is the normal cellular communication technology, or you may use the opportunistic use of the Seer network. The development of the bodycock network BNC controller with the Seer network is the research challenges for IoT enabled here. What are the architecture? Uh, it has three logical layer. Access layer comprising W band. Tier 1, it will operate in band 1, that is W band frequency. Backhaul convergence layer, that includes the centralized CRN cognitive radio network, and one tier 2 at frequency band 2 or tier 3 at band 3. So I have shown this is band 2, this is band 3. This is the backhaul convergence layer. and service layer comprising a remote server, tier 3. So this is the architecture. So bodycock BNC, the IoT enabled gateway, which we have designed properly, is a gateway interface between WBAN and CRN. The key design tool is the cross-layer based design with modified protocol stack of cognitive machine-to-machine communication is required to impose IoT functionality. We have patented this work and also published a journal paper on it. Bodycock BNC is designed to have active session management, because if you build a device following a particular protocol, you need to build the several interfaces for node-to-node communication. So active session management need to be there, and for communication, you has to be energy efficient communication. So when it is the backhaul network should be Seer enabled, we need to select the good Seer channel, and that has to be with a very short period of time. So we have applied convex optimization problem so that Seer can get instantly find the ideal channel. Switch to other licensed wide area network when Seer channel is not available. So these are the key features. So not always the Seer enable, but we have to have emergency service to allow through a licensed network. So cross-layer interaction among the layers, CRP, CRMAC, TCP layer has to be properly designed for proper communication, with the aim to build the energy efficient communication so that much energy is not obtained. So it has 5 modules: WBAN module, compression module, TCP/IP client module, cross-layer based Seer module, management entity. So this is the ultimately the solution we have built. This is Seer enabled IoT solution. We have used the open wireless open access platform, which is a trans receiving system designed by Mango Communication USA. That radio communication operate in 2 bands, 2.4 gigahertz and 5.8 gigahertz band, 5.7 gigahertz band. So we have used the word board as the Seer network, and GSM module, GSM SIM card to the one network. We have built the bodycock communication system. You let us see what is the different protocol module here. WBAN sensor node using IEEE 802.1516 following the fee layer. The spectrum sensing would be happening. We have designed bodycock BNC. So this has to be built a CRP, because we have to communicate with the central CBA, Seer base station at the physical layer, which is a wireless communication in a different frequency band. So we have to build the communication protocol to follow. Cognitive base station is based on the word board we have at our laboratory. Then the third, the cognitive base station has a gateway interface to communicate it to the remote server area, which is based on IP. This is what is called the total application domain. I shall see without much, because time is up. This is the actual test bed implementation. You see, this is different ECG sensor is applied to the design network, WBAN Seer enabled network. So 433 megahertz WBAN working in this band, it sends the sense data and come to this end. Then the bodycock BNC is built within this platform. So it will transmit the data on the Seer base station. This is another word bit board. Cognitive base station is there. Cognitive base station connected with a gateway router to internet to send it to the remote server. And you mind that though the actual signal is operating at 433 megahertz, but here it is because of the other frequency in the cognitive wireless base station, it is operating in 2.4 gigahertz carrier frequency. And this sort of ECG signal we have obtained. I shall show you a real video demonstration. Please observe it.
We have created a test bed setup to show the implementation of the proposed bodycock BNC for remote health monitoring over the bodycock architecture. which comprises of a wireless body area network over cognitive radio backhaul. We will cover the major components of this setup one by one. First, we have the ECG sensor node that captures ECG signals through AD8232 sensor. The Arduino microcontroller unit of this ECG sensor node seamlessly communicates with the BNC and transmits the ECG samples collected by the sensor using the CC1101 transceiver over 433 MHz band. Second comes the proposed body of BNC. It comprises of number one, an MCU that controls W-band communication. Number two, a body of BNC microcontroller unit termed as BCU to perform the BDWT based data compression and also act as the BAB that performs cross-layer based interaction with BCR MAC. And number three, a CR module incorporating BCR MAC in a workboard to control cross-layer interaction between CR5 and BME, and also to support functions like spectrum sensing, spectrum agility, and handoff. Now, WARP operates at 2.4 GHz unlicensed ISM band. Therefore, we model the channels in the 2.4 GHz bands to be licensed to primary users following an exponential on-off traffic distribution. We will see this shortly. And lastly, we have a PC efficiently monitoring the activities of the body of BNC via a serial monitoring tool called OM-tunnel software. For modeling a primary user system, we have utilized two laptops with built-in 100 Mbps Wi-Fi modules to emulate the incumbent primary user transmitter and receiver pair with exponential on-off traffic. Next, we have a cognitive base station CBS designed using a workboard that uses two radio throttle cards, one for the control channel and the other for data transmission and reception. We also have a PC that efficiently monitors the activities of the CBS via a serial monitoring tool called POTI. Now, the data received at CBS is sent to the remote server through a gateway router that connects to the internet. This PC here shows the remote server. The remote server is actually physically located somewhere else. However, here we are remotely accessing that remote server. At the remote server, a server application program SAP receives the data and extracts the DWT coefficients for further processing. An inverse DWT of the received samples gives back the original ECG signal. So, these are some of the major components of a setup. Now, let's see a demo of the actual transmission of a 2-second ECG data over the cognitive radio backhaul link. First, we activate the ECG sensor nodes. Then the data received at the body of BNC is transferred to the CBS. And finally, the data is received at the remote server.
So here,
let us take a closer look at each of the steps. Upon activating the ECG sensor node, we see that the data received at the body of BNC is transferred to the CBS. Here we show the activities of the CBS. The CBS receives data from the BNC and then forwards them to the internet gateway from where it goes to the remote server. Obviously, the data is transferred from the BNC to the CBS over a Seer channel that is licensed to primary users, but at instances when the primary user is not transmitting. This is the primary user signal that is received at the PU receiver. As you can see, the PU activity is modeled as an exponential on-off distribution. The average time period is kept at 3 seconds. We modify the average on and off times according to the required PU activity. Here, we are showing a 20% PU activity. Now, let's take a quick look at the functioning behind this normal operation that we have just seen by looking at the PCs monitoring the BNC and the CBS. First, we will see the BME activities through the OM-tunnel software. Also, we'll look at the BNC WARP activities, the CBS activities, and lastly, the remote server. As we can see, when the BME, which is part of the BCU, wants to start a server session, it sends a connection request to BCR MAC asking for a free channel from the CBS. Accordingly, on reception of a beacon from a CBS, the BCR MAC sends a channel request to their CBS and waits for a successful channel assignment message. When the channel assignment message is received, BCR MAC implements ISTO. And in ISTO, obtains the optimal intersensing duration, BCR MAC sends connection accepted message to BME. Next, when the transmission is finished, the BME will send a disconnect request to PCR MAC. The PCR MAC will release its channel to the CBS. The interchange of channel release request and its corresponding channel released message from the CBS. And that is how the body of BNC operates under normal conditions. Now, we could not show the PCR activities as the BME PCR link was scanned by the COM-tunnel software to study the BME activities. But now, we will do a ping test from a computer connected to the BNC ward running the PCR MAC and try to reach the CBS that is also connected to another computer. So, we will see that when the connection is established between the BNC and the CBS, the sensing and the transmission cycle starts and the BNC computer will be able to successfully ping the CBS computer. Now that we have seen the normal functioning of body clock BNC, let's see how efficiently it handles handoff. The BNC performs a handoff when it senses the channel allocated by the CBS busy a couple of times. Let's see how it achieves this. In this setup, we set the PU activity of channel number 9 to 50% and that of another adjacent channel number 5 to 20% PU activity. As we can see, the PCM sends a channel change request to the CBS from the current assigned channel number 9 to another relatively free channel. The CBS complies by sending a new data channel number 5 for further transmission. Now, to understand how PCR map takes the decision to send a channel change request, we have to take a look at the ping test. So, as we can see, when the PCR Max senses the channel busy for 2 successive times, it assumes that primary user is present in the assigned channel and it therefore triggers the handoff procedure. The last thing that we will show is the ability of body of BNC to switch to licensed wide area network technology like GSM, when the PCR Mac observes that there are no available suitable channels in the CRM. We term this as the spectrum agility feature of our proposed body of BNC. Let's take a closer look at how this happens. As we can see, this time the CBS doesn't have any free channels to assign to the PCR map. The PCR map informs the BME about this. The BME now intelligently connects to the remote server through GSM and transfers the data. Finally, let's take a quick look at the PCR MAC activities for carrying out this spectrum agility. As you can see, after the CBS informs that there are no available channels, the PCR MAC sends code 0 to the BME, informing the BME that the CBS is now disconnected and it should switch to licensed wide area network technology like GSM for further communication. That's all about our proposed body of BNC. Thank you for watching this video.
Okay, so you have seen the real-time demonstration. I am sorry, it is time is off. So I conclude my presentation. In the presentation, I have outlined the possibility of Seer-enabled IoT technologies, their issues, challenges, and several standardization efforts at present going on. Many direction yet to be worked on. You may get the very application areas. Okay, healthcare would be one of the thrust area for developing some IoT enabled application. So we have seen the IoT Seer enabled W-band application with the various development stages. It indicates the suitability of designing such architecture. The novel cross-layer based IoT enabled gateway is designed for W-band over cognitive radio backhaul for energy efficient and cost-effective remote health monitoring system. And a remote ECG monitoring use case is implemented on a TCP/IP client server-based design. So you remember that IoT and Seer, IoT, Seer enabled IoT need the energy efficient and spectrum utilization, better spectrum utilization. You have to devise the spectral compression, data compression technology. So bi-orthogonal 4.4 wavelet filter was found to most suitable, providing 67% signal compression with less than 2% information loss. So data with the compression technology has to be transferred. 64% faster in terms of execution speed and 2% more memory efficient as compared to traditional DWD, digital wave transform. So bodycock architecture easily extensible with different standards and technologies in future for remote health monitoring system and other non-medical IoT based application. It is also useful. So these are the research papers and patent. Mainly the work is on my student Tanumay Manna, implementation analysis cognitive radio enabled intelligent W-band gateway for cost efficient remote monitoring, published in Elsevier. Another is IEEE transaction and mobile computing. There are several conference paper also. We have applied some of the patent here on this thing, and the relevant standardization process are already there. These are the some of the W-band Cr IoT related papers. So I acknowledge the contribution of Broadband Wireless Communication Lab ETC's department and special contribution of my student Dr. Tanumay Manna for his work and video. So thank you all. If you have any question, I am ready to answer. I'm sorry I could not see your faces. This is a very unlikely situation. I am presenting very blindly, but it is thankful that is the communication is clear, I think. So you may ask some question if you have.
So please, if anyone have any question, raise your hand so that I can unmute you.